So again, my name is Jack Kearns, and I'm from the University of Houston. And today I'm going to be talking about some applications of GPS for research in the Houston metropolitan area. A little bit of what I want to cover in addition to that is some current research that we're doing with some other GPS-enabled technologies, such as LiDAR. My team and I have been studying GPS in the greater Houston metropolitan area for approximately 4 years now. And I'll talk a little bit more about that as this slideshow progresses. Something you'll notice in Figure A is what we call the Greater Houston Metropolitan Area that is monitored by the HoustonNet, which was created for the purpose of subsidence monitoring. This is a screenshot from the UNAVCO data archive. All this data is publicly available and can be traced back to 2012, so feel free to download it at your convenience. Almost all of our GPS antennas resemble the one that you see at Kirk Elementary in Figure B. However, we build GPS antennas and stations in a myriad of different ways. Another thing you see right here in the study area of the Houston metropolitan area is that we not only have GPS stations, but we have extensometers, and we have co-located groundwater wells that we use to correlate groundwater measurements with subsidence measurements. What you see in our study area is that some of our results indicate that subsidence is heavily linked to groundwater withdrawal. In particular, in our area, it's linked to groundwater withdrawal in the Chico and Evangeline aquifer, which is still being withdrawn up north. Now, as far as a reference frame is concerned, though, we have no ability to track GPS or subsidence monitoring with any level of precision without a local reference frame. This one's created by Dr. Wang at the University of Houston, and with this reference frame, we can track motion down to a sub-centimeter level. Typically, it is 2 to 3 millimeters in the horizontal and 6 to 8 in the vertical. You also note that we use 10 long history stable GPS stations outside the area. Some of the results that we have gotten so far indicate that our GPS is highly reliable, and we know this because we compare it with an extensometer at Addix, Texas. And you can see the GPS measurements in red, which follow the extensometer measurements in black. And for the most part, what we can also see is by pairing it with the groundwater level measurements is that groundwater is restored to its pre-consolidation head. Subsidence in our area will begin to slow and then ultimately cease. Proposed future studies. What we'd like to do next is continue to study subsidence in the northwestern portion of Houston, which you can see in the red circles. And in that area, it has not been controlled by groundwater regulations, such as in the area that is filled in with yellow. And so in that area, subsidence is continuing to occur where it's all but ceased in the area that's filled in with yellow. In the area in yellow, although subsidence has ceased, there's an anomalous region that is so far unexplained. Now, what we speculate is it might be attributed to petroleum withdrawal. And this is an image of the subsidence area that you see right here. And in the black area, the black points that you see is subsidence that is just running along like you would not believe, similar to what it was in 1914, whenever subsidence was at its highest in that region. And so knowing that and understanding that it may be attributed to petroleum withdrawal, we've begun a preliminary investigation into that anomalous region. And so whenever we begin to go ahead and plot the amount of oil wells in Galveston County, which is part of the greater Houston metropolitan area, we see that we have a huge cluster of oil and gas wells within that area. So as of the moment, we're beginning to obtain production data as well as withdrawal data. And hopefully in the next probably half a year, we'll have a paper out about this. All right, so within that area, we also have several things located at the University of Houston Coastal Center, which is right next to one of those wells. And we have a whole series of GPS arrays, well water measurement devices, and something I want to really note is the GPS antenna that is larger than all of the other ones out there. We created that one in the lab in order to make a GPS antenna hooked up to a TripleNet R9 float on the groundwater surface, a downhole well. And so we're still waiting results on that. Something that we've just begun doing as well are LiDAR measurements. And with these LiDAR measurements, we've begun mapping out faults. We've also begun mapping the Slingillian landslide in Colorado. And not only that, but we've also begun conducting a coastal erosion study in Freeport, Texas, which is about 60 miles south of the University of Houston. Again, results are still coming, and hopefully in the future we'll have something out about this. And so this is our HoustonNet and LiDAR team in various stages of the construction, and hopefully we'll be able to continue to expand and maintain the network for a lot of time to come. So thank you all so much, and a special thanks to Jamie, Tanya, and Linda for helping us get here and get squared away.